Hello, everyone, and welcome to Learnable Computer Science. This is the last class which we'll be here together. So this is a class where we will just be reviewing everything that we have learned. So hopefully, you all are having an amazing day. Hopefully you all have watched all the previous videos, and it brings me great pain to say that this is the last class that we'll have together for Python. So let's get into it as we go into data types. So hopefully you all know what the data type is. I'm just going to review through the entire course once again for the final test. But the final test will not have the introduction to data science libraries, so there's no need for you to worry about that. But for everything else will be tested. So first thing is data types. So we have four main data types, which is an int, which is basically an integer, like 6, 342, -17. You have float, which is decimal numbers, 3.14, 3.14, 7.0, and all of the decimal numbers. We have booleans, which is either true or false. And we have strings, which is text in Python, which is immutable. So you cannot change a string after you have made it. You cannot specifically change specific characters inside of a string. Okay, next we have variables. So it's basically like a container to hold data types, and it points to certain values to something stored in memory. For example, if there's x is equal to 5, x is the container and 5 is the value, and 5 is being placed in the container. Imagine 5 as a cookies and x as a jar. You're putting cookies in the jar, and whenever you call x, you call 5. And when y is equal to x is 5, so y is equal to 5, and z is equal to high. So that's string. You can also assign strings as well. Now we go on to the statements. So there's print and input. So print basically prints out a data type of your choosing to the console. So if it's print hello world, print 3, print 8.2937, print with nothing in it, or print true, all of it gets printed out. So hello world, 8.2937, and then true. And then the space and then if there's nothing in the print, it just prints out a empty line. And there's also input. So it gets input from the user, and typecasting is important here. So if you do name is equal to input, what is your name? This is at this point, it's not necessary to say str, but if you say like, what is your age? Then you need to have int here. And then you say like, what is your name, David? And you say, hello, David. So you do int input, str input, float input. You can do all that kind of stuff, but like automatically the input function gets a string. So if you want to convert it to an integer, you have to put int in the front or float in the front. So there's no need for you to put str in the front though. But this is just for the simplicity sake of kind of explaining what it does. Okay, now we're going to if, elif, else statements. So these are the statements that utilize the conditionals. The conditionals are basically like it uses booleans to figure out whether something is correct or not. For example, if 3 is equal to 4, or if false or true is equal to true or false, you can do something like that. And then the first thing to run is if. So if checks that if the if statement is correct, then it does a statement, and everything else after that will be skipped. The elif statement is optional, but if you do have an elif statement, the next thing to execute if the if statement is not correct is the elif statement. And then you can do as many elif statements as you can, and it checks each one until one is correct. Or if none of them is correct, you can have an else statement, which again is optional. And then with the else statement, if none of the above conditions worked, this will definitely work. Next, we go into loops. So we have the while loop and for loop. So the while loop runs as many times as it takes to accomplish a task. So until a condition is met. So until a condition is met. So it's pretty similar to an if statement, except while runs as much time as it needs to fulfill the conditional, while the if statement, it just runs it once. So it's good for loops that don't have an estimated number of times. For example, you wash the dishes until all of them are done, or you mow your lawn until it's fully mowed. You do not know how many dishes there are, and you don't know how and you don't know how much square yards your lawn is, hopefully. I mean, if you do, that's amazing. That's an amazing thing to know. But not a lot of people will. So if you don't know how many times you need to run, having a while loop is very, very useful. And the for loop on the other hand runs for a specific number of time, and it's easier to write, so good for loops that don't have an estimated number of time. For example, do 30 sit-ups, write I love Python 20 times in your notebook. And you see here, there's like an else statement here. You're like, what is this? So this is optional. So execute only when loop executes normally. So this is like, it runs, but the else statement is like executes only when the loop executes normally. So if the loop does not execute normally, this won't run. But like, again, we did not learn the else statement block. I never seen anyone use the else statement block, so don't even worry about that. Just worry about the while loop and the for loop. But this is just another syntax that you may want to know. So that's why I've included it. Okay, now we have function syntax. So we have the function name here. Actually, let me start over. We have the define. We have a define number. We have a define syntax here, which the def means define, and then we have the function name, which is an identifier call when the function is called. So when you want to call this function, use the function name, and then we have parentheses, and the arguments or parameters is optional. Just think of, we didn't specify what arguments is. That's exactly the same word as parameters. So just it's completely interchangeable. But like parameters are like values that are passed into a function to allow for more functionality. But this is optional. Parameters are optional, but these two are, and the parentheses is required as well. And the function body is like, it's executed each time the function is called. So when you call a function, the function body runs. And then the return value, which is optional, ends the function call and sends data back to the program. For example, if you say get age as your function name, and you call get age and you return 10, where the get age function is being called, you replace that with 10 because that's the return value. That's basically what the function syntax is. It's basically similar to an if statement, except you call the function rather than the function testing if something is correct. So if statement's kind of like the central thing, and then there's multiple branches off of it, if you think about it like that. Hopefully that makes it a little bit easier to kind of think about functions and while loops and for loops. Yeah, and parameters are basically the thing that we have discussed before. This is parameter, this is a return value. So it's basically like additional information we pass in, and return types is like we allow code to extend off of the program, and it makes it so much easier to kind of connect the programs together. And then now we're going to modules. So there's a random module and math module. So the random module is like a module based on random, and it gives random functions. So to call it, you simply import random. And then we discussed the function randrange. So randrange is basically like, there's an optional start, there's a stop, and then there's a step. So it's the same as randint if you remember, but it has more functionality. And like, for example, it's a start. If you have the start as 0, and you have the stop as 10, and the step is 1, so it's 0, 1, 2, 3. So if you have a start as 0, step as no, sorry. If you have the start as 0 and step as 10, it'll go from 0 to 9, because you have to do the stop is equal to the the number that you put in minus step. For example, because so the easier way to think about it is the first parameter is where you want the range to start, but the second number is where you want the range to stop. So you don't want that number. So it's the one before that. So for example, step means increments like 1, 3, 5. or 2, 7, 13. For the 1, 3, 5, the step is 2, and for 2, 7, 13, the step is 5. So if you put the step as 2 here, and it's from 0 to 11, it's 0, 2, 4, 6, 8, 10, and it won't go any more than that. And then we have the math module, which allows us, so it's a module that gives more functionality to do math. And there's no need for us to code them because it's already written, and as they're complex math functions. And the ones that we went over are math.pow and math.square root, and math.pow returns the base of the power of the exponent, and the math.square root returns the square root of the number. And we went over lists. So the list syntax is we have the variable here, and it basically allows us to store multiple data types into one variable, which is very useful for like passwords and grocery lists, all that kind of stuff, all use lists. So you do list is equal to, and then you have 3 elements, and they say if you print list here, it just prints them very nicely like this. And there's a list here, and it's surrounded by brackets. So the square brackets are what allows it to still have one value inside of one variable, but inside of that one value, there's multiple different data types. And there's list functions. So list.append adds an element to the end of the list. List.index returns the first position of occurrence of the element passed in. List.insert, you give the index and the element, and it inserts it at the specified place. And then there's list.pop, which removes the element which you have specified as the index. And there's, again, for the random module and math module, there's so many more functions. Please feel free to look at that whenever you want. And here are the links to the list functions as well. So if you want, you can take a look at all these. There's so many functions that Python offers. It's truly remarkable. So if you're interested, so please look at those as well. Now let's go into OOP. Oh, this is kind of tiring. This is basically like the entire course going over in such a short amount of time. So we have spent the past couple of weeks trying to go deep into each of the topics, and now just going through all of them is super challenging. But hopefully this is very helpful. This took a long time. So if this was helpful, please be sure to let us know in like the forum of the Learnable website. That would be greatly appreciated. So now, since the intermission is done, please feel free to take a break. Take a break as we go on to the next to the next half. So if you want, you can take a quick drink of water. So, or just eat a snack. I'm going to take a quick drink of water. Oh, okay. So hopefully, you're staying hydrated, and let's get into it again. So now we're going into OOP thinking, or object-oriented programming thinking. So there's two parts of object-oriented programming. One is attributes, the other is behaviors. Attributes are the thing that the object has, while the behaviors are the thing that the object does. So for example, attributes of a phone can be screen, model, brand, and the attributes of a book can be title, author, price, because it has them, but the behaviors are what the object does. So for example, a dog behavior might include barking, cuddling, playing, and a computer may include running OS, watching videos, and practicing coding on Learnable. So while an attributes are the thing that the object has, behaviors are the thing that the object does, which is really important. And to make an object, we have constructors, and the constructor basically makes the object. So the thing that we code is a class, but whenever time we pass in values like here, book is equal to book, and you pass in certain values. This is an object because a class is an overarching thing, while an object is a specific blueprint of that. For example, if you say car, right? You can say Lamborghini is a car, right? That is a relationship. So Lamborghini. So if you have a car class, you can specify a Lamborghini inside of that. So a Lamborghini is the object and the car is a class. So it basically initializes all the attributes and it's always required, even if it has nothing in it. And in this example, a book has a title, author, and price. And it is basically initializing all the attributes to its own attributes as well. So when you want to call the attributes, you use this name, not the title. This name, self dot dash dash title. And that's same for author and price as well. Next, we have getters and setters. So this is where we have the behaviors. So the getters gets the information from the object and setters sets the information from outside. And then you can morph the object using these functions. And you may ask why even have these. It's basically because you want to add more functionality to your program and things may change, right? You even have you may simply say like we don't need to, we can just simply change it directly, right? Like that, but it's like, and you also may be asking why we even have the dashes here, because all the other ones say self dot title, self dot author, self dot price without the dashes, but the dashes make the attributes private and not accessible outside of this file. So if you have a dash there, it makes it private and not accessible to this file. The reason why I'm doing this and why others interestingly do not is simply because we do not want others to look at our object. For example, you don't want random people to just peek inside of your house and see what's happening, right? You want to keep that to yourself, or you want to keep that to your family. So they have to ask you permission to look inside of your house. The getters, you have to look permission. And then the setters are, can I come into your house? Or can I or can I replace the TV? Those are setters. You're changing the attributes. So that's the reason why we have it, because you don't want other people to look inside of your house, right? You want to ask them permission. So this is why we have that. So this is the thing called encapsulation, which is again a very, very important topic that you will definitely use as you grow older and go into job and internships. So this is super important. It may seem tedious, but it's super, super important. And then we have like additional functions like the read function. You can have the read function, which basically prints reading for the book class that we had. And you could also have the reproduce function, which basically prints out the object the way you'd like to be printed out. And this is basically because you do not want when you're printing it out, right? When you print it out, it just randomly prints out without the repro function, without the reproduce function. It just randomly prints out like random letters and numbers, which is basically the address of where the location is, which is not at all useful to us. So that's why having the reproduce function, where we specify what exactly we want it to be printed once we print book, is very, very useful. So I'd highly recommend doing that. And no always includes self as parameters for all functions. So for example, you see self here, you see self as all the parameters for this, even though we don't use the parameters, always include it, because this basically shows Python that this belongs to the object. And now let's go into inheritance. So we have the superclass and we have the parent class and the superclass. And the parent class is the class that's being inherited from, and the child class is the class that's inheriting the code. So if you have a class person as a parent class, you can have a child class that says student. And it basically allows us to reuse the code from person inside of student, which is really useful because you don't want to write the code again. You want to reuse the code that you already written. Okay, so that's basically it. So this is basically inheritance. we won't go into the introduction to data types. No, we won't go into the introduction of data science, as that was more of a thing just to like learn more about the boundaries outside of the basics. So this is until all we'll do. So if you do class student, right, just making sure if you all understand. If you do class student parentheses person, this is a thing called an is a relationship. So a student is a person, right? It cannot be flipped. So like if you have student, so if you have the parent class as student and you have a child class as a person is not a student. Like there's many other types of people. So like for example, a person can be a worker. They can be they can work in a job. They can they don't need to have a job. They're unemployed, or they can be in college, or they can be a professor. They're not exactly a student. So that's why we cannot do person is a student. We do student is a person. Just just example how like an animal is not a dog. A dog is an animal, but an animal is not a dog. So that's why animal should be the parent class, and then dog should be the child class. Hopefully that makes sense. So this is the final test that we have for this course. This basically has all the topics that we have covered except the introduction to data science libraries. So everything that we reviewed in this video will be tested. So feel free to watch this video. Feel free to watch the video multiple times if you need to have practice. You can also go back to the videos that we have included for the previous topics as well, where we go through practice problems, code together, and homework review. So you can look at all of those. And hopefully everything kind of makes sense. If you have any questions, please feel free to email me at sailalitkanamuri@gmail.com. It's SAILALITHKANUMURI@gmail.com. So please email me if you have any questions, or you can join the weekly tutoring programs that we have at Learnable, and I'll be more than happy to help you. So the QR code here is for the final exam on Google Forms. Again, thank you so much for going through this course. It means a lot to us at Learnable and to me. So hope you learned a thing or two about Python and computer science. And again, if you have any questions, please be sure to join our tutoring programs. And I'll definitely see you later. Bye-bye. Thank you so much for all your amazing hard work. And I wish you all the best and all the skill for your later future in computer science. Bye-bye.